Hello my dear students, this is Akash SD and welcome to the ASD physics classes. So students, I hope so you all are doing very well for the upcoming JEE exam, CBSE exam and after that NEET exam. So students, in this class we are going to learn about the relation between gravitational field intensity and the gravitational potential, and after that we are going to solve 3 questions, most probable questions that can come in a NEET and JEE exam. So students, let's start the video and let's learn what is the relation between GFI and GP. So students, here what I have done here I have taken one point mass capital M, and at a distance of small r I have taken one observation point P. Now the magnitude of GFI at point P due to mass capital M is given by, you know very well, GFI is the vector quantity, but why I am writing here the magnitude? Because I have to compare this GFI as a vector quantity to the GP as a scalar quantity. So to make this comparison possible in a very proper way, we are writing the magnitude of GFI not in a vector form. Okay, so what we can write here, the magnitude of the GFI I equal to Gm by r square. Make it equation 1. Now at the same point P, GP is given by here V equal to minus Gm by r, and as I told you very well, the value of the GP is maximum where? At infinite, and at all the points in the space the value of GP will be always negative. Why? Because the force between two masses is always attractive, that's why this GP will be negative. Now after that students, if I can multiply and divide with the r, then it will become here minus Gm by r square and into r. Hence we can write here this V equal to minus I into r. Is it? And this I am writing from which equation? From equation 1, this equation. Now if I want to make some general formulas and all that is applicable in a constant GFI GP and variable GFI GP also. So in that situation we have to just shift this observation point very small length. So let's take this observation point P is shifted by very small length dr. So what will happen? When the observation point from M will increase, then what will happen? As we are going away, then in this situation what will happen? The GP will increase. Is it? As I told you, no? At infinite GP is the maximum and at all the places negative. When we are moving towards the infinite point, the GP will increase. Okay. So in this situation what will happen? That as the GP will increase, so for very small displacement, what we can write here, just let me write here, for small displacement, for small displacement of point P. And how much is small displacement, students? This is small displacement is dr. So here we can write here, as the GP will be changed by the very small value, so we can write here dV is equal to minus I into dr. This is the normal formula. So from here I can write here I equal to minus dV by dr. This is the normal formula, but how to use in a questions and all that? For that students, I will just write here few formulas here. Let's take formula for 1D. So here please, here students, here please, this I equal to what I told you, minus dV by dr. But if we want to write in the x direction, then it will become here minus dV by dx. Similarly, if I want to write in a y direction, then Iy equal to minus dV by dy. Similarly, in a z direction, what to write here? I equal to minus dV by dz. Is it? And you can use the suffix also, like this. Similarly, if I want to write this equation in a 3-dimension equation. So in 3-dimension students, what will happen that here? Let me write here. See, this vector I is equal to minus del V by del x I cap plus del V by del y j cap plus del V by del z k cap. Both these formulas we have to use whenever in the question V is given and we have to calculate the I. After that, this is the one thing. Next one, students, see here please. Now if in case E is given and we have to calculate the V, then what we have to do? We have to use this formula, as we know very well, dV equal to minus E dr. We will write in a vector form, is it? And after that this one here. And here which kind of product is there? This is the dot product, because the product of two dot product will only can give us the scalar quantity here. That's why here the dot product is there, and after that here we will put the lower limits down and upper limit up. Is it? So all these formulas will be required to solve the further questions. Okay students, so let's solve the question here. So students, you can see here, if gravitational potential in a region is given by V equal to 3x square plus 5, then gravitational field intensity at 2, 1, how much here? Now, so here we have to use first kind of formula. So what is happening? This is along the x direction. So we will write for the x, this one here, Ix is equal to minus dv by dx. Is it? Now what we'll do here? We will put the value of x. So minus d by dx, and here how much? 3x square plus 5. Is it? After that here please here minus, and we can simplify this here, d by dx of 3x square. So x square is here, this 3 will come outside, plus d by dx of 5. Now then what will come here? Minus 3 differentiation of x square by using the formula nx n minus 1, it will come here 2x, plus differentiation of constant is 0. Hence we can write here, this will come how much here? This will come minus 6x. Minus 6x. Now we have to get the value at which point? The value of x how much given? 2. So we'll write here at x equal to 2. So it will come here minus 6 into 12 minus 12. And unit Newton per kg. Newton per kg. So which option is correct, students? Here you can see the correct answer is here option D. So in this question we have solved from the 1D point of view. If in case here they have given y 3y square plus 5, then we have to use here iy equal to minus dv by dr. And remember that one more thing here, this minus sign indicates that this GFI in which direction? We can tell 12 Newton per kg along negative x direction. Please remember that this minus sign is having the meaning, directional meaning. Okay. Now students, after that let's move to the next one please. Again for the 3D point of view. If gravitational potential in a region is given by xy plus yz square plus 2zx cube joule per kg, then gravitational field intensity at this point minus 1, 1, minus 1. This is x value minus 1, y value 1 and z value minus 1. So to solve this question we will use the 3D concept. Is it? So now to solve this question, first what we will do? We will calculate del v by del x, del v by del y, del v by del z separate, and then after that we will put in a equation. So see here please students, if I want to calculate del v by del x, the meaning is that dv by dx, but what is constant? This y and z is a constant. Is it? So see here please here, d by dx, put the value of v please, xy plus yz square plus 2z x cube. Is it? So now after that when we will simplify this here, what will happen? What are the things constant? Y and z constant. That means anyhow this term is going to be 0 because differentiation of constant is 0. Now the d by dx of xy how much? As we know y is constant, that means d by dx of x plus, after that here also students as z is constant, so we can write here plus 2z and differentiation of what is this? X cube. So what this will happen here? Here please, y differentiation of x how much? 1 plus 2z and differentiation of x cube how much? This will become here 3x square. That means overall we can tell y plus 6z x square. And now after that the value of y how much? 1 plus 6. The value of z how much? Minus 1. And value of x how much? Again minus 1 square. So when you will simplify this, it will come minus 6 plus 1 and it will come minus 5. I will write here. Del v by del x came how much here? Minus 5. Same page. So del v by del y will come what here? dv by dy. And here what is constant? Here the students, here x and z will be constant. X and z will be constant. Is it? So now again we'll write here d by dy, and please put the values please, xy plus yz square plus 2zx cube. So now as what is constant? X and z is constant. So which term will become 0? This term is going to become 0. Even no need to touch this, and after that we will simplify this here. So again, what I'm telling here, this x is constant, d by dy of y, plus after that z square is constant and d by dy of y. So what will become here? X differentiation of y is 1 plus z square and d by dy of y also 1. That means it will come here what? X plus z square. Is it, students? Now the value of x how much? The value of x minus 1 plus value of z how much? Minus 1 square. So what this will come here? This value is coming 0. Is it? So students, let me write here itself. This del v by del y is coming how much? 0. So students, if we'll do for the z directions here, please, dv by dz, delta v by delta z. What this will come here? Dv by dz, and what is constant, students? This x and y is constant. Is it? So it will come here d by dz, put the value of v xy plus yz square plus 2z x cube. Now students, what other things are constants here, please? As I told that x and y is constant, that means anyhow this will give how much value? 0 value. Then after that here, please, y into d by dz of z square plus after that see please 2x cube into d by dz of z. So here y differentiation of z square how much here? 2z plus 2x cube, and here how much will come here? 1. Now students, let's put the values. Is it? So here please, here value of y how much here? Value of y is 1 into 2. Value of z how much here? Minus 1 plus here 2. Now, and value of x how much here? See please, minus 1 cube and into 1. So when you will simplify this, it will come here minus 4. Is it? That means if I write here, the value of del v by delta z will be how much? Minus 4. Now I think so you are getting the smell of the answer. Is it? Smell of the answer. So as we know, what we know, as I equal to formula, I how much there? I equal to minus del v by del x I cap. So del v by del x how much came here? Minus 5 I cap plus del v by del y how much? 0 j cap plus del v by del z how much coming? Minus 4 k cap. Minus 4 k cap here. Is it? Minus 4 k cap here. Minus 4 k cap. So this minus will be multiplied inside. So it will come here 5 I cap plus 4 k cap. That means you can match the answer. The correct answer is how much here? 5 I cap plus 4 k. We'll go next. Next one, we are going to see this one here. Now the gravitational field is there, and what we have to calculate? We have to calculate the GP. So students here, please here, if gravitational field in a region is given by this one, E equal to minus xi cap minus 2y j cap, then gravitational potential at 2, 1 is how much? And the GP at 0, 0 is given how much? Joule per kg. Remember that here? In 12th we use E, and in 11th we use I. I means gravitational field intensity, E means electrical field intensity. Even sometimes I, E interchangeably also we use it. So for that no need to worry. So students, for that which formula we have to use here? We know that the formula. What is the formula? See please here. dV equal to minus E dr. Now this is the formula integration. Now what is the value of the E? Put the value please. Minus xi cap minus 2y j cap, and this dr is the displacement vector, and it is given in terms of I cap and j cap. So we will write dxi cap plus dy j cap. Dz k cap no need to write. If 3 dimension means we can write dz k cap also. So we'll write here dxi cap plus dy j cap. After that we will just take the dot product here. No? So this minus is here. Just take the dot product, students. So it will become here minus x into dx plus minus x into dx, and this minus plus minus minus 2y into dy. Is it? And anyhow this integration sign is there. Okay. Now after that what will happen that here? Anyhow this minus will come outside. Now so we can write here, see, this dv is equal to x dx plus 2y dy. X dx plus 2y dy. Is it? And we have to put the integrations also. Is it? So here please, this is the integration, this is the integration, and here also integration. And now we have to put the limit. Now lower limit is what? 0, 0. So when x is 0, y is 0, then potential how much? 1. Now potential is how much? 1. We'll write here V equal to 1. Now after that, at which point we have to calculate 2, 1. That means x coordinate is the 2, y coordinate is the 1, and there we have to calculate the potential. Let's take their potential is how much? V1. Is it? So students, here what will happen? That here, let's see here. Integration of the dv is the V1 to V1 is equal to integration of the x dx, x square by 2. By using the formula x to the power n plus 1 by n plus 1. This is 0, this is 2, plus here 2, integration of the y dy, y square by 2, 0 to 1. So this 2 and this 2 is cancelled. So first we have to put the upper limit, then we have to put the lower limit. So here upper limit means V1, lower limit is I1. Here when you will put the upper limit and lower limit, it will come anyhow 2 square by 2 minus 0 square by 2. So it will come here 2 plus here upper limit means 1 square minus 0 square. So anyhow it will come here 1. So after solving it will come V1 equal to 4 and unit joule per kg. Is it? So which option is correct here, students? This option. Okay. So students, in this class we have learned the relation between GFI and GP and the question. So just keep watching my videos regularly. Thank you so much.